History.
All right, let's take a look at what's called a Hohmann transfer. This is the technique you'd use if you're in a rocket ship and you're in a circular orbit. You want to change your orbit altitude. All right, so right now we got this rocket that's going around in a circular orbit, and it's at height 1 grid. And let's say we wanted this to be at a height of 2 grids. You might think that, well, why don't I just fire my rockets to apply a force this way to just make it higher, right? Well, that has a number of problems with it. Number one, you need to adjust the speed, because in order to be in a circular orbit like this, it's going to have to be going slower. The speed of the orbit is already defined. It's going to be the square root of g times the mass of the star divided by the radius of the orbit. Since the radius of the orbit is increasing, it must be going slower when it's like that, and just sending it straight out like that's not going to slow it down. The other problem with that is that you would be applying a force in this direction with very little displacement, because it has no velocity this way. You'd always be sending forces out this way at right angles, radial to the path, and you'd be wasting a lot of energy, and you can't do that with a rocket because fuel is really valuable. So what you're going to do is this: to maximize the energy transfer to the rocket. Okay, so we're going to fire here, and we're going to fire in the direction of the velocity. That way, it's also in the direction of displacement, and that way you maximize the work done, the energy transferred to the rocket. All right, so then what happens is when you're here and you fire it, you're giving it kinetic energy. And so it can no longer follow this path because of its inertia, so it starts gaining height, right? And hopefully you gave it enough, you did enough work to it to get it to this height. So when it goes, it's going to slow down, gets to here, maximum height, and then it's got to start falling back and speeding up. And it continues in that orbit, that elliptical orbit. And when we come around again, I think we're going to fire our rockets again, actually one more. And we're going to fire the rocket again to give it kinetic energy. Boom! And we gave it enough so it gained altitude, and it was just enough. It's going at the right speed and the right height, and we're in a nice circular orbit. At this point, the total energy is 1/2 the gravitational potential energy, and the kinetic energy is minus 1/2 the gravitational potential energy. So that's how you get into a circular orbit. That is called a Hohmann transfer. When you do that to get to a higher orbit, and that's how spaceships work.
History.